So what are the steps for the creation of universe? So basically create one project, then create a connection. This connection is a one-time activity. If the connection is already there, you can reuse it. You don't need to create the connection once again. Like for example, if I have created the connection to the backend database, we all can reuse the same connection for all the universes where the source of data is this database. Now, the next step is creating a data foundation. Let me open that IDT tool.
Ganesh?
Yeah, Krishna.
But let's say I have a colleague of mine who has created a connection and he has published to the repository. How do I import that connection?
Yes, I'll show them. So you just need to go to their to the repository and say that create a relational shortcut. We'll do that. So say for example, yesterday we created that connection. Okay? Now I would like to reuse that connection, or let's say you are okay, actually to create a new project. So ZE fashion. Right? So yesterday we created one connection, so that is there in the repository. So now go to repository, expand your user ID connections. So navigate to the folder. I think this is the folder where I created a connection. You want to reuse this connection, right? So you can just simply right click and say create relational shortcut. Which project you want to associate. So the shortcut is created. Now you can proceed with the next step. Clear, okay. Krishna?
Yeah. Thank you.
So now if you select this connection, test it before you use it. So it's saying test failed. Let's see why. So why? Because here I'm using a user admin, right? So the ODBC connection we created, as I'm not a admin on the yesterday I created not with our admin credentials. So that ODBC connection is specific to the user ID. Okay, so that's why it got failed. Now if you go to change connection, either I need to log in with the same user ID because it's a remote desktop. So trainer. So let me open IDT. Now let me create a relational shortcut. So go to repository, connect to the repository. Connections. So here we have create a relational shortcut. So now you can see this connection. So double click, test the connection. It's working fine. So basically, because the ODBC connection which we created, so that was a user DSL because I didn't. You will not have the you will not have administrator rights on this remote desktop. So that's why I asked you to create a user DSL. If it is a on your computer, what you need to do? So you need to create a system DSL. System DSL is for all users. So that's the error. So this is how you can reuse a connection. Okay. Now, if you want to reuse this connection, what you need to do? You have to create a user DSN with the same name. Okay. Either I need to create a system DSN. This one, if I go to, either I need to create a system DSN so that everyone can use it, or you have to create a user DSN with this name. But again, this is a one-time activity. Once you do it for all the connections, I mean, it would be using the same driver. So now we created this connection. Now, basically, I'll proceed to the next step that is called data foundation. So data foundation is our modeling layer. I mean, the actual modeling within the universe will happen in data foundation. So let me open SQL Server. So here we have this database tables. Okay, let's go ahead, select the select your project, right click on new. What I would like to do, foundation. So give the data foundation name. So I'll say BO training underscore fashion or data foundation. Data foundation on fashion tables. Click on next. Single source or multi-source. Okay. So this is the design, right? So if you ask me why are we creating data foundation, so what is the answer? That is a part of the universe design. See, what are we doing in the universe? We are creating a data model, right? So that data model will be done in the data foundation. That's where you are going to join these tables and then create a relationship between these tables. Okay. So yeah, so fine, thank you. So here you can see when you're creating a data foundation, it's asking whether you want to go for a single source or multi-source. Single source meaning all the tables which you require for this universe design are there in one database. It is single source. If you have, let's say, 20 tables required for this universe and 10 tables are in this and another 10 tables in a different database, then you have to create multiple connections, one for each database. Then you need to go for multi-source. So we'll discuss the multi-source in the coming sessions. So for now, let's focus on single source. We have all the data within one database only, that is SQL Server. Click on next. Secured connection. You always need to select the secured connection. Even if you have a local connection, click on finish. Okay. Now, if you expand this connection, you can go to the eFashion database. So here you can see these tables, the same tables what you see in the database, right? Now, if you observe these tables, we said that this is a data warehouse, meaning you're storing the data in the denormalized fashion. What is denormalization? Now, if you see this data, now in the transactional system, how do we store the data? So this is related to sales, right? Now, in this, a very simple example, every time a customer performs a sales transaction, so this is how the data would be there. Like for example, So sales ID, then customer ID. So which product? Okay, so basically product sales, basically transaction date. Okay, so which store this particular transaction is happening, or the sales employee. Okay, so quantity, amount. Okay, or any discount if applied, something like that. So this is how we store the data in the transaction system, right? So particular customer C1. So who is that C1? So you'll go to the master data table of C1. So then here you'll have a customer ID, customer name, so his country. Or this data, this is transactional data. So this transactional data might be spread across multiple tables. So let's understand with a different scenario. Okay, so first let's complete this and then I'll explain with one more example. So customer ID C1, so some name and he belongs to some country. So purchased a particular product P1. Okay, so again a product master data table. So sales date. So basically, if the transaction is happening today, so today's date will be recorded. Okay, the employee ID who is handling this transaction. So if you go to the employee master table, you will find so which store he is basically in operating or okay. So then if the employees can move from one store to another store, so we might need to even record the store ID, quantity sold, amount sold. So this is the way how you store the data in the operational system, transaction system, OLTP, right? So OLTP and data warehouse. Now, so this kind of data is required for my transactional system in the OLTP for the billing required related details. But for now, for my reporting, I might not require all this data like which customer taking which product on which date, etc. I'm interested about see the sales here, fact table. So the table which is holding your measures, these are called measures. Margin, amount sold, quantity sold. What are these? These are measures. What is a measure? Quantifiable objects, quantifiable data. So give me examples of measure. So in this example, like you can see, margin, amount sold, quantity sold, these are measures. The rest all are dimension objects. Now, for example, if we talk about employee ID, okay, my employee ID is let's say 3311. Is it a measure? Right? Can you just please respond to me in the chat room quickly? So is that going to be a measure? Yeah. So that's not a measure. So it's a dimension object. So anything which is quantifiable, it's a measure. So for example, so quantifiable data or measurable data, also called as facts, key figures. So same. So different names used. Okay, so in BO we call them as measures. So examples: stock in the warehouse, number of employees, headcount, sales, okay, product price, okay, so quantity sold, order quantity, okay, delivered quantity, sales margin. So all these are measurable data, key figures. Okay. This employee salary. Okay, all these are measures, quantifiable data. Okay. Now, when it comes to the denormalization, so we are talking about OLTP and data warehouse, right? So when it comes to denormalized schema, what you do is you bring all the transactional data into one central table that is called fact table. Okay. So in the transactional, in the OLTP system, this data, what you see here, this might be in several tables, but you bring it into one central table and you aggregate it. So here, for example, I'm storing data by customer. Okay. So different customers, let's say C1 to C10, purchase the same product. Okay, on the same day. Likewise, on a different date. So now what we are doing here, you're storing that particular product. Okay, you're storing that particular product at the week level and store level. So you're aggregating the data in the fact table at the product level, at the week level. And then you're bringing all this transactional data into one central table. So that is called fact table. Okay, so fact table is the one which stores your transactional data where you have your measures. So another example. So for example, here let's say we have a purchase order. Okay, PO header or sales header or anything. Okay, so you have document number. Okay, see, from I'm a manager for procurement. Okay, I am responsible for procuring materials from several vendors. So I placed a purchase order to buy some materials from a vendor. Okay, so that PO details would be stored in several tables. It will not be there in one table. So that is what we discussed. That is normalization. Normalization meaning when you store the data, you split the data into more number of tables. So here you have a header table with document number. So from which company this, okay, the company code, into which vendor this order is placed. Okay, so what is the order date? Then like payment terms, etc. Okay, so this is header table. Then we have one more table, item. So in the item table, here you can see this is the primary key. So what is primary key? Sorry, whatever is the color. So this is the primary key, meaning every purchase order will have a unique ID, a order number, right? So that is unique. So this is the primary key in this table. So now if you see the other table, so if I so let's take some document number 4711. So this is the order number. Okay. So my company code is something. So GXLN. So if you want the details of this company code, what we'll do, we'll go to a table for the company code master data. So that refers to some company RB UK London. This is the company code. Okay, that's the description. So it's located in UK London, etc. So this is the company code. So this is the company code master data table. Okay. So what are the details of that company code? You will refer here. So you placed an order to a vendor, okay, V1. So again, the vendor master data tables will be there in another table. So vendor V1 refers to some guy, so that some company, okay, that's a different. You placed an order on Jan 25th, okay, 2015. So this is the header table. Header table will only have what is the order number, from which company to which vendor, what date, so high level information. Now in this order, you might have ordered multiple products, right? So I want to buy some 10 products. You don't create 10 purchase orders. Within one purchase order, you will specify how many materials you want. So what is the total quantity, etc. Right? So this is material. Then how much quantity? Okay. Then the order amount. So in this order, so I'm requesting, I'm placing an order for three materials. Okay, M1, M2, M3. So what is material M1? You need to go to the material master data table. Okay, M2 likewise. So this one I have placed a quantity of 15. The total order amount is 450 USD. Okay, so this is I have placed an order for 13. So this is like 500 USD. So this is how the transactional data would be stored in the OLTP system. Data would be spread across multiple tables. In fact, now you will see one more table, okay, with the order status. Okay, there would be another table called PO status. Then there would be one more table like PO schedule. So, for example, in the PO schedule line table, now, okay, so let's say quantity, let's say I have ordered some very big quantity, 1500. So let me change this to when giving some bulk order. I don't want this 1500 units to be shipped at once. Okay, so I don't want the delivery, all this quantity to be delivered at once. I want some partial deliveries, meaning send in different schedules. So I'll have another table. Document number, item, okay, schedule line number. Then here we'll have order date. Okay, so one more column. Yeah, sorry, this is order date. Sorry. So here we'll have, let's say, delivery date. And then here we'll have delivered quantity. Okay. So just keeping it simple, I'll remove this column. Fine. So meaning this particular material, okay, don't send me all this quantity at once. So send it in 3 schedules. So on basically the vendor agreed sent a delivery on, when is this order? Jan 25th. So on Jan 29th, okay, out of this 800, 700, sorry, what is the quantity? 1500, right? So 1500, so let's say 400 units is delivered. Okay, then on 3rd of Feb, another 350 is delivered. Okay, on 7th of Feb, or let's say on 15th of Feb. Okay, so let's say someone another 370 is delivered. Okay, so this is the delivered quantity by, I mean, if you see, okay, let's say currently we are in Feb 17th, for example. Okay, now till date, so how much is the quantity delivered? 1120. So what is the open quantity still? 300. Okay, so this way, data is stored in multiple tables in the transactional system. Header table, item table, status table, schedule line table. Now for one report, if I want to see like the vendor level data, so what is the total order quantity, what is the delivered quantity, I want to see how much is the open quantity, okay, by vendor. So for this vendor, let's say I have placed some 20 orders for this company code. Now I want to run a report. I would like to see this way. In the month of January, the month of February, okay, so how many orders are placed to this guy? Okay, what is the total order quantity? So how much is delivered? Then how much is open? So this is a one simple report I would like to generate. So for this, how many tables, from which tables we need to get the data? So all the 3 tables, right? So think about the data volume. Let's say this table is having some 50,000 orders. Now in each order, on an average, if you are having 3 materials or 2 materials, so 50,000 into 2, they are scheduled in 3 deliveries into 3. So now think about the data volume likewise. Okay, so you're going to have huge amount of data in these transaction tables, because obviously transaction data would be very huge. A lot of purchase orders are being raised every day. Agree? Now a join, if I want to see this report, you need to join these 3 big tables. So now think, if it is having a million records, this will have, let's say 3 million, this will have some 9 million. A join between these many records is going to be very bad in performance. So that's why the reporting performance on the OLTP system, normalized schema. This is normalized schema. Okay. So for the PO schedule, how does it know the material number to schedule? It only knows the document number. So this is the item is there now. Item is unique. Okay, so this is the primary key. So material M1 meaning item number 10. Okay. Okay, Jose, are you clear? See, to answer your question, what is the question? Yeah. How does it know the material number to schedule? It only knows the document number. Okay. So here you have document number and item number. So item 10 refers to material 1. So now if I have this 4711 and item 20, this is material 2. Okay. So then material 2, M2, send me on 4th of Feb. First is the first it is delivered on 4th Feb. Okay, so this item is the material. Technically, you are just assigning some number. Now going back to our So now you can see this data is coming from so many tables like company code master data table. So in the report, if I just show this company code, user will kick me. So he will ask me which company code. I can't remember every company code name. So I also need to show the company code name. Likewise, I also need to show the vendor name. Then material name, material ID, material name. Then these joins. The biggest problem is join between these tables. I need to join from document number to document number item to document number and item. And this is going to be huge amount of data, a million, 3 million, 9 million. So, but you need to store the data in the OLTP system at that level because for the day-to-day transactions or for the OLTP related operations, you require that data. So this is normalized schema. That's why the reporting is not faster in the OLTP system. What do? We bring this data into data warehouse. When the ETL process runs, the ETL team will join all these tables during the load time and bring all this transactional data into one central table that is called fact table. Okay. Now that would be connected with. So in the fact table, in this case, what I'll do, I'll just store material. Okay. So if I am designing a fact table for this, I'll have material. Then vendor company code. If I'm interested for day level reporting, okay, if there is a requirement to see the data by day, I'll include day. Otherwise, I'll include month or week at which level you want to see the data. Okay, then I will include order amount. The order quantity. Okay, then order amount and delivered quantity. Okay, so this data I will store it in one central table. So how I'll have the data? So I have 3 materials. Okay, then if I have a different order, let's say 4811. Okay, so we might have placed another order on March, or let's say on Jan 27th. Okay, on Jan 27th I have placed another order. So in that order also I might have ordered the same materials. Okay. M1, some amount. Okay, yeah, so let's discuss that. So now here I have this data. What I'll do, I'm storing the data by month. So material M1, so which company code? This company code to the same vendor. In the month of January, okay, I'm not storing the order date, I'm storing data by month. And what is the total quantity? So here 1500 plus 1400. So 2900 is the total order quantity. Okay, what is the total order amount? So this one plus this one, so whatever it is, so it's, let's say 18,450. Delivered quantity, let's say here 700. So how much is delivered? Let me add this order number again. Okay. Again in the month of January, so you'll only consider January data. Okay, so let's say I have delivered some 700 on same date, 29th Jan. Is 700 plus 400, 1100. So this is my fact table. So fact table combines the data from multiple transactional tables, okay, and have your aggregated data. Why you need to store this way? Two things: you are avoiding joins. Now, if I do reporting on top of this table, the joins between these big tables are eliminated, and then I'm aggregating the data by material. So you are summarizing the data. Definitely, if you remember, I mean, if you think it logically, when you are analyzing the data, okay, when you are analyzing what is that you are looking at. So how much is my open quantity by vendor by month? You're not really interested about so which order, how much quantity you placed, etc. You can also do that kind of reporting. Okay. So if you want to see by order level data, then extend this table. So for my analytical reporting, I'm looking at the material level. I really will not go by the line item level data for my reporting. Okay. So this is called fact table. What is fact table? So fact table is a transactional table which combines the data from several OLTP transactional tables where the measures are stored in an aggregated format.
Ganesh,
Yeah.
let's say we have a project and the data structure is maintained very badly in a particular backend system, be it either data warehouse or a regular RDBMS. So can we improve any kind of data structure when we get the data from universe kind of thing? Like, can we improve the data structure in the universe level, or we have to go
Sorry.
back to the back end and say like we have to improve the data structure there itself?
Krishna, sorry, I didn't follow the question. Like, what do you say? Data structure is not maintained. Meaning,
Let's say in this particular case, they haven't maintained the data structure properly. Means the way the reporting needs are or the way the reporting requirements are, like if the
okay,
data
okay.
structure is not maintained properly, like not so much
Like for example, the data
back.
model is not designed in a particular uh, flexible manner. Like it's not scalable for future requirements.
Yeah. So can we improve the data structure in the universe level?
That would be very tough in case if the data is not maintained at the required level, right? See, for example, in this case, what are we doing? I'm not storing the data by order date, and I'm storing the data by month.
Yeah.
So then, if I don't have the day level data, again, you want to remodel the data, so that might be tough.
Okay.
Okay, so that would require the backend changes.
Oh, got it.
So now everyone clear? So for example, how many fact tables will I have for this PO data? Tell me. So you are combining data from multiple transaction tables into one central fact table. Thereby, you are eliminating the join and then you are decreasing the data volume. Why? Because see, now here you have how many records? So three, and here you might have some nine. Good. So instead, you are storing this data in one record. So the data volume will be reduced, meaning in the transactional system, let me see the number of records in this table, right click and say count rows. There are 89,000 records here. The same data which is in this table, if you go to OLTP system, that might be into 10 or into 15. Obviously, the data volume will be very huge in the transactional system. When you bring the data to the data warehouse, what do? You summarize the data at which level you require. You store only at that level. Now, if you see this fact table, what are you doing? Article ID. Article ID is nothing but a material or a product material. Article ID same. Okay. So of particular color. Let's say this product is offered in 3 colors. Let's take a laptop. It's a MacBook offered in 3 colors. So you want to see which color is being made more liked by the customer. So you're storing data by color. In week one, okay, or then in store one, okay, what is the sales? Then in the same week, next store. So if you see the data here in this table, right click and say show table values. The same products of this color in week one in store one, store two, store three. Which store? You have the shop ID. You need to go to the store table. What is that entry? So right click, go to table values. The store ID is something. So this one in this store. So likewise, you're storing the data by week, by store, by product.
So Ganesh, here you cannot have day level reporting at all, right? Like the maximum
Yes,
you can go is up to a week,
is a
I
week level.
guess.
Yes,
Once you have them.
yes, that's right. Yeah. So once I load this table, if you want day level data, there is no way. I have to delete this data or create a separate table, etc. So this is called granularity. At what granularity we have data here? It's the week level granularity. Week level, product level, and store level. If I include the transaction date here, sales date, the granularity is at the day level. Now, so are you clear what is a fact table? Everyone? Anyone has a question? So question here is, yeah, will the fact table will have facts from all the dimension tables? Yes. So granularity. Granularity is nothing but at what detailed level we are storing the data here, right? We are storing the data by week. What is this amount sold? This is the sales happened in the week 127. So some week ID. So in this week, 7 days are there, right? So in these 7 days, what are the total sales happened on this product? This total sales amount. You are storing this. So what is the granularity? Week. At what detail level? How much granular it is? Now in the fact table, if I include the transaction date. Now what is the granularity? Day level granularity. Clear? Okay. Yes. So now, so for example, here what I am doing, I am storing month. So when you include month in the fact table, these two orders data is combined into one record. Instead, if you include order date, what will happen? This order amount is the sum of these two values, this one and this one. Now you have to split that. So you will say order date. So if you remove order date, now tell me what is the granularity here? Can everyone please reply me? So what is the granularity of this table if I remove this order date? Month. Right? Everyone agree with me? If I include order date, so this record I have to split it to two records. Okay, so one on 25th and one on 27th. So the granularity is at the date level. Okay. So in this example, if you see here, what is the granularity? Week level granularity. We are storing the data by week. So if you ask me on this report, if I can see daily sales, you can't do it. You have already you have already aggregated the values. You did the sum of revenues sales by week. There is no chance now. You have to bring the data again from this OLTP system. Okay. Now you have these tables. So other question is from Rabindra. I think the question is, can we bring date? Yes, that is one possibility. Okay. So we'll see with a different example that one. Here, instead of storing week ID, week level data, what I can do is I can include date and then add one more table which stores the date level data, date and year, etc. I can join that. Yes, that is a possibility, Ravindra. But in this case, data is already stored by week. Okay, we can also see that example. Yeah, so here instead of storing the week ID, then we can have order date. Yeah, that can be done. Okay, so what is a fact table? Fact table is the one which stores your transactional data where you have your measures in an aggregated format. Now here you have dimension tables, so these are called dimension tables. Products. How many the store is selling some 200 products, so here you will have 200 records. So what is this 211? So product ID is the primary key. Every product has a unique record. Now tell me, which table will be big in size, fact table or dimension table? Okay, can everyone please reply me? So which table will have more number of records, a dimension table or a fact table?
Dimension.
No, fact table. Why? Because see, there is one product 100. So that product number of records will be in the product table. You will have only one record for every product. You will have only one record. Product ID is the primary key. That product purchased in 10 weeks in 10 stores, you will have 100 records here. Okay. So if I have 211 products, see the number of records. If I have 211 products, the number of records in the fact table would be 89,000 records. So it's so big. Always transactional data will be more. So when I join these two tables, this join will not be a performance problem. Okay, when I join will be performance will be impacting the performance when the join are between two large tables. So this transactional tables, here I have a million records, here I have 3 million. That join is very bad. But here you might have some maximum, let's say, okay, let's say some 10 lakh records. So the transactional data can be in millions or billions. Okay, so this join will not be having performance issues. Similarly, this store, okay, the number of records in this table will be, what does this 13 mean? That means this is having 13 stores. Again, this join will not be so bad. Okay, so this is called star schema, a fact table at the center connected with dimension tables. So fact table at the center connected with the dimension tables. So this is called star schema, that is called denormalized schema. Okay, now why did we do this joins? Because see, I'm storing the data by product. I would like to see what is the revenue by product category. So what I'll do, I'll join these two tables and then I'll do a group by, I'll do the sum of values by category. So here I'm storing data by week. If I would like to see the data by year, what is the revenue by year? So what I need to do, I need to join these two tables. So double click this join. What kind of join it is? It is an inner join. So see the join clause, the where clause, cardinality. So here article ID is primary key. Here article ID is foreign key. What is primary key? For every product you have in this table, you will have more than one record in this fact table. So the cardinality will be 1:n. Okay, so set the cardinality. You can also right click and say detect cardinality. System will automatically set it for us by looking into the data. But if the tables are not updated with proper data, the cardinality might set incorrectly. Okay, so mostly, so this is called data foundation. So you are designing a data model. We'll see it will be more complex than this. Okay? As we are in the first session, I'm keeping this universe very simple. Save the data foundation. Now let's go to business layer. Any questions on this so far? Would there be any requirement to connect this product table with store table, etc.? No, why? We will not have that requirement. Why? Because you want to analyze your measures, okay, by product or by time period or by store. So let me create a business layer. That is the next step.
Hey, Ganesh.
Yeah.
So you just brought up a good point actually, but if you go back to your data foundation just for a second. So now, yeah, most of the times I am looking to analyze measures. You are perfectly right on that. But let's say I just want a simple report that says which articles are stored in which stores, kind of thing. Should I still go through the fact table, or can I join the product and store table and just get that kind of information? I'm not interested on quantities or so. So I need a report that says like, oh, this particular store is selling these products. So
Yeah. So that we can get it through the join through the fact table. Okay, so we don't
still
need
have to
to
go through the fact
join.
table.
Yeah, yeah.
Okay. Okay. Thank you.
So now, yeah. So what is the next step? We are done with the data foundation. The next step is to create a business layer and then save it in the repository for our reporting. Okay. So select your project, right click, click on new. I would like to create a new business layer. So give the universe name. So business layer name is nothing but business layer is your universe. I mean, this entire all these layers are universe, but whatever the business layer name you give, that will be your universe name.
Don't you need to publish your data foundation to the business office repository or something?
When you publish the business layer, it actually takes the data foundation.
Oh,
Okay. Yeah. So connection should be published. It's made as an independent one so that you can reuse the connection. Business layer and data foundation can be published at once. So we don't individually publish the data foundation. Okay, you will not find that option. Now select your package, right click, click on new business layer, relational data foundation. We created a relational connection. If you remember yesterday, we talked about what is relational connection. Then give the universe name. So universe name can be anything. Give some name, for example, let's say SBO, SAP Business Objects underscore June underscore eFashion. I'm giving you some unique name so that there are, if you are creating this eFashion universe, so 10 universes will be created with the same name. So just to keep it unique, I'm saying some name universe eFashion. Easiest thing is give it as a eFashion sales, the universe name. Click on next. select the data foundation. Okay, so here there is a checkbox, automatically create folders and objects, uncheck it. Okay, click on finish. Okay, so now this is your data foundation. In the business layer, you create objects which makes your reporting faster, easier, flexible. Meaning, let's see, let me open an existing universe. Okay, so now I selected one universe called e-fashion. Okay, so this has this folder structure. When I expand these folders, I see some objects. Now, if I drag and drop, query is generated. This is the sales by state and city. But the question is, how did we get these folders and when these objects? So that is the business layer, design. Now let's do that. So these are called as classes and objects. Okay, so these are called class and objects. These folders are called classes. So what does a business layer have? Classes and objects. So class is a logical grouping of objects. Meaning you place all product related details into the product class, product line, product category, product number, product description, product color, product price, store related details in a separate folder. So that is called class. Store in which the state in which the store is located, city in which the store is located. Okay, this is not the state of customer. Okay, this is store. Okay, so that is the meaning of class. You have objects, right? So these are called objects. So different icons are there. Colors are different. So first one is called measure objects. Just now we discussed what is a measure. So measure objects.
Means, uh, is there any, will there be any issue if I put every object in the same class or something?
Yes, we'll see that.
Okay.
Okay. When you drill down, okay, like for example, I'm seeing the data by product line. I want to drill down to category. Okay, so the report, how the report should drill down, that also depends on this class. And another thing is navigation for the user. See, sometimes end users will create their own web reports. So if you put all these objects in one class, so searching basically, searching your objects would be very tedious. Okay, so that is also another reason why you create a class. So then now we have dimension objects. This is characteristic data or descriptive data. For example, now we already discussed what is a measure. Like for example, revenue, salary, quantity sold. Okay, so all this is measure objects. So dimension data would be, now can you tell me here in this example, so which all can be a dimension object? So in this, yeah, can everyone please reply? Material is a dimension object, company code, vendor, month. Okay, all these are dimension objects. Quantity, order amount, delivered quantity, these are measures. Agree? Any questions on that? So this is characteristic data like material, vendor, company code, okay, state, city, employee ID, all these are dimension objects. Then here I also have the next type of object that is called detailed objects. Detailed objects are so additional information about dimension objects, meaning so which is not used for data analysis. Okay, for example, so if you see material, okay, the material weight, material weight or material color, okay, material type, material, yeah. So these are, what is this data? So this is additional information about material. Now if you see, usually I don't run what is the sales revenue by the material weight, right? We don't do that kind of analysis. We say that what is the revenue by material, but you want to see some additional information about that material, material description, the material weight, material type, etc. So those kind of objects are detailed objects. Okay, so here if you see, yeah, those are attributes. That's right. Attributes or detailed objects, same. Okay, so these are measures. So these are dimension objects. Now, if you see the store name, okay, when you expand the store, you will see the store attributes, store address, store zip code, and the zip code in which the store is located. So these are store master, attributes or detailed objects. In BO terminology, we call it as detailed object, nothing but an attribute. That's right. Okay. So in the business layer, you need to define these classes and objects. Let's see how to do that. So first I create 4 folders. These are called classes. So I have 4 different distinct data. So one is double click on this folder. I'll rename this to products, to store, time period, and one folder for measures. Okay. Now add your objects. So in the product class, I'll add product line code or product line. When you create these objects, create them in the business terminology. Don't include like the technical words, because some users would be using, they would be creating their own Webby reports. So once we give the universe, so these objects should be in the business terminology. Now if you see here, we have product line, category, product number. So instead of using these technical names like family name, article ID, etc. Okay, so create them in the business terminology. So double click and rename this object to say lines, say product line or family name. So that can be a description for the object. I'll add category, okay, then product. So instead of article label, I'll keep it as product name or product description. Then I will include the product ID. Okay. So here again I will rename it to product ID instead of article ID. Product line, category, product name, category. Then price can be an attribute of this. So I can add price, right click and say turn into attribute of products. This is an attribute. Now in the store, so state, city, manager operating the store, store name. The store attributes like store address, zip code, what I'll do, floor space, etc. I will add them as attributes. detailed objects or attributes, anything is same. So convert it as an attribute, right click, say turn into attribute or detailed object, both are same. Shop name. Okay. Then year, double click this, so instead of YR, give it some meaningful name, year, quarter, month, then measures, which are the measures, revenue, amount sold. Now convert them into measures, select this, right click, turn into measure with aggregation function sum. Okay. Now rename them instead of amount sold and keep it as a meaningful name, sales revenue.
Does it create automatically the sum function, the query? Oh yeah, I see that. Okay.
Yeah. So when you define that as a aggregation function sum, so here you can see the select, it's going to add the sum function. Why? Because you need to aggregate the data, right? So when we say, so what is the revenue by state? So if I need to do it in regular SQL, what I'll do? Select state, sum of amount, join these tables group by state. So to enable that option, so yeah. So here I have shop name. If I want shop ID, yes, I can add that here. I missed it. So I'll add the shop ID. Okay, so dimension objects, detailed objects, measure objects. Now save your business layer. Before you publish, first you need to validate it, right? So first you have to verify whether this particular universe is working fine. Okay, so you can create some sample queries, test queries. So remember this, these queries you are creating are not used by user. They are not used by the end user. These queries you create in the business layer are for your testing. Okay, now I'll create a query. So first I would like to see revenue by state and city. Here you can see the output. What happens if you go to script? An SQL code is generated based on the joins we did. So that is the whole purpose of this universe and baby. Automating your SQL generation. You don't need to manually write any single line of code, or in most of the cases you don't need to write code. Okay. If you observe this generated SQL code, you can see a join is there. So this join you did it in the fact table, sorry, in the data foundation. You joined the store table with the fact table based on shop ID. Then you are using the sum function in the measure. So where is sum function? Where did we use that? So here, if you see, we converted into a measure. Right click, say, you're saying turn into measure with aggregation function sum. Double click, the function sum function is added. So as there is a sum function added, so the group by will be automatically generated. So now let's verify if the queries are running fine. I'll say sales by state, execute the query. Likewise, you can create multiple test queries and then manually compare the data. You might need to go to the underlying tables, do the sum, okay, by firing SQL queries individually. Okay. So now I'm done with the business layer creation. Save it. I will now publish this to the repository. Select the business layer, right click on publish, publish to repository. Click on next. Let me create one folder for our batch. Universe is successfully published. Now you can go ahead and create Webby reports on top of that. So there are many things which needs to be discussed in the universe, but this is a very basic level universe. Okay, clear? Any questions so far? So when we say universe, universe is a combination of these three. Connection used to, the connection will identify what is the source table. So where is that source data? The data foundation will define what is the data model. The business layer will define, okay, the business layer will define the objects. Okay, the universe is the combination of connection, business layer, and data foundation. So this is a very high level universe design. So we'll get into the details of this universe, like each and every object, and
Can
we'll get
one
into
Ganesh, sorry to interrupt. Can one business layer have more than one data foundations?
no. It has to be, all the design has to be in one data foundation.
So it's always one to one then. Okay.
Yeah.
Okay.
So I'll give a very simple universe for you to work. Okay. So first what we need to do is, first we need to understand at a very basic level. So you can take, for example, with some 10 to 13 records, very simple data. Okay. Yeah, yes, Pawan, I will explain that. Okay. See, when you have, so there is something called insert view here, right? When you have so many tables, in this case we have only 4 tables, right? When I have a huge number of tables, a universe might have some 100 and 150 tables. So looking into all those tables in one single screen, analyzing those joins would be very tough, right? So I can go for a different views, and then I can see these tables and joins by the application area. Okay, so that's just a view. So let me explain one
So
simple
you can't
assignment.
create business layer based out of view.
Business layer based out of view, meaning I don't understand.
Like you created a view in your data foundation layer, I guess, right?
Yeah.
So can you create a business layer based out of means again view is also a set of joints, right? Like a table instead of all the four things you will have.
Right. See, no, whether in the business layer you are creating from the master view or the sub views, it means the same.
Mm,
You are you are just taking few tables out of it.
yeah.
Yeah, you can do that. It's nothing but you're just seeing the let's say I'm having 100 tables in the master view. I created a sub view with 10 tables related to the sales.
Mm-hmm.
Then you create a business layer on top of that. It means that you are seeing only 10 tables. Okay. So just for our visualization, those views, it's not impacting anything. Okay. So just to uh, see when we have like 150 tables in one screen, it would be very tough to analyze these joins. So I organize them into different views.
Yeah.
So what if you add one more table? You created business layer for data foundation. Data foundation has 5 tables. In this case, we have 4 tables. Now, after that, you have requirement to add one more table. So do you go back to the business foundation and add the table, or you start from the scratch again?
You simply enhance this business, this data foundation. Let's say I want to add one more table, so I'll add this.
So you go back to the data function and add the table, basically. Okay.
Yes, you have to do that at the data foundation level. I'll join this, then save it. Automatically, the structure will be shown in the business layer. This is my business layer.
And Ganesh, once you have published a universe to the business objects repository, any changes to that? Are you still working on the local copy, or are you from there on? Are you working on the direct business objects repository?
Even you published it to the repository, you are still working on the local copy. So every time you do a change, you have to publish it again.
Okay. So even if I accidentally delete or do something wrong, I can always get the data back from the business objects repository, I guess, right?
Yes, that's right. Right.
Okay.
So if I delete the business layer here, if I delete all these objects, also I can still right click and say retrieve a published universe.
Okay. 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 Thank you.
Yeah.
It's more like a restoring than you from publish universe.
Yeah.
Yeah, kind of, because
Mhm.
sometimes
Pub,
if you
yeah. Right. Yeah. Publish is nothing but you are saving the local copy in the server.
Right.
Retrieve is opening the copy on your local machine from the server.
Okay. Oh.
So just give me 2 minutes. I'm searching for some files. Okay. So let's see this very simple example. Okay. So you can create a universe and then on top of this, you can work on this as an assignment. Okay. So this is one table, product master data table, employee master data. So here I have country ID. So the country's description, country names are there here. Then customer master data table. And this is the fact table, sales ID, customer, product, employee ID, and amount. Okay, 1 minute. Okay, so I'll explain the assignment and then we'll close the session for today. So very simple example. Okay, see here. Now this is a product table, employee table, customer table, and country table. Okay, here you have the sales table. Tell me out of this, which is a fact table?
The sales table seems to be.
Yeah, so this is a fact table. Obviously, we are very clear that you are storing the transaction data and you have the measures. Now, I'll upload this data into the SQL server. So create a universe on top of these tables, okay, and then analyze the data. So you create a Webby report, or basically you create a query using IDT, right? So
Country information in the fact table. Can you just go back to it?
yeah, 1 minute. So create some queries in the IDT and then verify this data. Yeah, yes. Yeah, I don't have country information in the fact table. Employee country,
Uh,
customer country. Okay. So so fact table will be joined on customer, country will be joined here.
sure.
Okay. So these tables I will upload in SQL Server. Okay. So your task is to create a universe on top of this and then verify the query results should show this way. Yeah. Okay. Yeah. In SQL Server, I am going to create a database with the name sales. Okay. So let me do that quickly. Okay. So I'll create one database with the name sales. Right click, click on new database. Yeah, I'll give the database name as sales. So here a database is created. Okay. Now let me upload this data into that SQL server into different tables. So this is my Excel file. Yeah, it's found.
Hello,
Yeah, found.
can you hear me?
Yes, yes, yes. Tell me.
Uh, uh, Hello, Ganesh. I had one question. We just there's one project we're going to start this week. They have developed the universe on different database. I think it's the SQL Server. They're moving to Teradata. So
Hmm.
I open their save the existing universe, trying to open onto different server, but I'm unable to open that into the different server because I need to basically analyze that universe, but I'm unable to open that universe. Do you know like how can I save that like in some sort of standalone that universe so I can open that existing universe into another server. Is there any way that is possible?
It's IDT or UDT?
It's in IDT. They build in the IDT, it's in different database. Now they migrated to the Teradata. So all I want to open that universe into different server. So I save as that universe into my local and then I basically try to open into different server, but I'm not able to. I'm not sure
You
that.
should be able to.
Uh,
You should be able to open the data foundation and business layer. You might not see the data because uh, basically you need to change the connection. You need to change the connection, but this table structure you should open. You should be able to open that.
No, but
Possible.
I'm not
Yeah.
able to. I understood. That's not a problem. Definitely, is not give data. All I need that basically I need that structure, existing structure, so I can use that. So because they keep most 60-70% same, like some tables, but some of them they convert that into view as well. So, but what are happening when I save as when I'm opening into different server, it's asking my that old server details. It's not allowing me to open into the and when I give the my new existing server details, try to open that universe, it's saying no, you can't open it because it might build up something in a different universe. You can't open that universe into this server. So it not allow me to even open any data foundation or business layer. That's all I need to open data foundation. I just want to use that because they use around like 80, 90, I think more than 100 tables or something. So I don't want like build something from scratch. I just want like sort of base layer.
Yeah. So you need to have the ID and password of the other server, right? From where you are retrieving that
I
universe.
don't have because I am working only the new project. So I got that just that universe, but I'm unable to open into my existing universe. I won't be any details of the old server.
Maybe if you share your screen, we can look into it.
Okay, can you do it now or some other time?
Um, yeah, we can do it now. So first, let me complete this assignment part. Okay. So assignment would be like everyone, please. Here I have created this table called sales. Okay. So I created this database called sales. I'm going to upload data into this. Okay. So there are different ways to upload data. So you can just right click and say task, import data. I'm just going for an easy method. So I'll just import it from an Excel file. Okay. So I'll create one. I'll give the path of the Excel file, and I'm going to update this particular database. So in this database, you'll have tables like product, customer, employee, country, and sales or shop facts. So on top of this database, now you need to go ahead and create a universe. Okay. So everyone clear on the assignment part? Okay, so
Uh,
this recording will be available in the blog. Okay, so that would be available by Monday.
uh, Ganesh, will we have access to the same SQL server and
Yes.
remote machine?
Yeah. It would be, you will have access to the same SQL server and all the remote machine. Everything is same. Yes.
Have you informed Kavya to give the connection?
Yes.
Okay.
Yes. I have spoke to her, so you will get your access today.
Okay. Thank
Uh, yeah. Hi, Nisha. Good morning.
Good morning.
So Yeah, so this is our second session. Um, yeah, so you joined a bit late. So just check with Kavya. So the session recordings are available. So maybe you can go through them. Okay. You have any questions for me?
Uh, I just joined today. This is my first session.
Yeah. Okay. So I would advise to talk to Kavya. Okay. Training coordinator, and she would be giving access to a blog. So there the session recordings would be available. So go through those session recordings, and if we have any questions, we can discuss in the next session.
Okay.
Yeah. So you will have the session recordings and the other details like the support team contact, right? So CK, if you have any issues with the server, you need to talk to the support team. Okay. So in the blog, you will find the details of support team. So everyone clear on the assignment part and what needs to be done? Any other questions? Okay. Yeah. So your task is to create the universe. Yeah. Connection, business layer, data foundation, everything. Yes. Okay. Yeah. Thanks everyone. So we can meet in the next session.